when this starts. Okay. So hopefully this is allowed. We realized that all three of us are on campus, so we just decided to meet up. So here's everyone.
Hi.
And I'm going to try to set this camera so you can see most people. It's hard at the angle, but anyway, we're all here.
We are, yeah. Okay. Alrighty. So, okay, something I noticed on here that encourages us to start with a prayer, like at the very beginning. Yeah, I didn't even see that last time. So I think praying would be cool. Yeah. So I am actually gonna shut the door just so that it's start. Really dark. Woo. Good recording. If you don't mind, I can say it.
Okay, sounds great.
Okay. Our dear Heavenly Father, we are so grateful to be gathered to do our trigonometry group meeting. We pray that Thy Spirit will be with us as we seek to understand the principles that we will be going over, and that we can be able to understand and apply the things that we're learning. We're grateful. I'm grateful that Jared and Maria could come over and that we could be able to join together in person, even though this is an online class. It's a blessing for us. We love Thee and say these things in the name of Jesus Christ. Amen.
Yeah. Okay, so looking at this stuff.
Discussion.
Yeah. So did you guys try to do the extension problems yet?
No, I haven't. But I'm gonna get out.
Well, does everybody understand the 5 different transformations and the 5 important ones?
What is the fifth transformation?
Yeah, because I was like, there is A, B, C, and D.
Yeah, I didn't know what the fifth one was.
Would that be the exponent one?
The transformation.
There is one about the exponent that here I can show you.
Yeah, maybe. Because you've got like horizontal translations, vertical, and then the reflecting, stretching, and shrinking. Is that what we're talking about?
Yes.
Okay, so then I think that's it. So horizontal, reflecting, stretching, shrinking, and vertical. I think I have 5.
And what is the reflecting?
That one is A. It's when you have the minus.
Oh, it's just having a minus.
It reverses over the aces, everything.
Yeah, I think it just flip-flops it like a mirror.
Oh, okay.
Because I was looking at, and there is one that is in.
I don't know the.
Yeah, it does. But on this thing right here, if I get rid of this minus,
Everything goes.
okay, that was the power cord.
Okay.
I was like, oh no.
We lost it.
Yeah, so in here, if you get rid of that minus, it just like,
Oh, interesting.
Inverts
Okay,
it.
that's so helpful.
Yeah, it's
So I
just
guess-
literally flipping over.
I
Yeah,
guess that's the fifth one.
yeah, reflection.
Mhm.
So, let's see.
Discuss the 4 additional trigonometric functions. Is that like the? So that's just like.
Yeah, what are those?
Oh, I think it's the I don't know how to pronounce any of these, but like the tangent, cosecant, secant, and cotangent.
Oh,
Yes, because we already know sine and cos.
Sine, cosine, and tangent.
Yeah.
Yeah, so the 4 are the cotangent. That was one of them,
If
right?
there's sine, cosine, that's what we already knew, and then there's tangent,
Uh-huh.
and then cosecant.
Cosecant.
secant, and cotangent. And I took some notes here. So like the opposite, I don't know if this helps right here to see. But like the inverse of sine is cosecant, the inverse of cosine is secant, and the inverse of tangent is cotangent.
Cool. Yeah. So you just flip flop your
Yeah, so instead of like hypotenuse over adjacent for tangent, it's adjacent over, I'm sorry, opposite over adjacent, it's adjacent over opposite.
Yeah. Let me pull out
I
the
have a pencil out.
unit circle.
I think this real quick, just as my sister now.
Yeah, you're fine.
Hey, what's up? Hey, can you hear me? Sorry, you're connected to my Bluetooth headphones and my backpack. Hey, I'm in a meeting right now. Can I call you back later? Tonight? I may be able to tomorrow. Okay, I'll call you back in like an hour or two because I'm in a group meeting. Okay, well, I'll call you later. All right, bye. Cool.
Is your sister here on campus?
She is in, what is the place she's at? It's not Carriage House, but it's Avonlea Apartments.
Oh, okay. That's cool.
Yeah, so I think it's like down this way. We get toward, yeah, down this way and then like a little left.
Yeah.
Yeah.
Yeah, that makes sense. That's cool. I went with my brother before my mission. So it was actually in Virginia, but I loved it.
Where at?
At Southern Virginia University.
Oh yeah, I almost went there,
Oh yeah?
but they didn't have like what I was wanting. They don't have a lot there. It's pretty there though.
It's gorgeous. Yeah, it's so pretty. Yeah. Cool. So those are the four additional. So four additional meaning tangent, which we haven't really talked about in the other week. So that's number 4, right?
Mhm.
Tangent and then.
Do you know like the acronym? Do you remember cosine, sine, and tangent?
No.
So it's like called SOHCAHTOA. If you can remember that. So it's like sine is opposite over adjacent. So
So
wait, no,
SOH.
so no, SOH. So
SOH.
so it's like
sine
opposite
is
over
opposite over
hypotenuse.
hypotenuse.
And then CAH, CAH, opposite over hypotenuse. And then yeah, SOHCAHTOA. I saw that on YouTube.
What?
I have no idea how to memorize the other ones though.
Well, you just have to know that.
Were we not supposed to look at this last week? Where is it? Sorry, I got 30 million tabs open.
No worries.
Where was
So oh, that's so cool.
Do you know that interactive PowerPoint thing?
Oh, yeah.
The storyboard? Were we
Yeah.
not supposed to do that last week?
Yeah, I did it. I just did it.
Okay. Because it talks a lot about tangent stuff in there last.
And make you do it. It was
Oh,
really
yeah.
cool.
That was kind of neat.
It's like, yeah. It's
You're talking about the PowerPoint? Oh yeah.
The storyboard or whatever it's called.
Whatever. Yeah.
I actually have.
Yeah, it's pretty neat.
That's so brilliant, Kim.
But I don't remember. I have nothing to memorize the other ones other than.
You just need to know which
Oh,
one's
the
the
the opposite.
Yeah, you just gotta know which one's the opposite.
Yeah.
Yeah. Let's see that. Just reverse. Just get to
Yeah.
Cool.
Okay, and then number 3, review the answers to question number 6 from the prep.
So, okay. Here was one of my questions. So cosine usually refers to x, right?
Mm-hmm.
And sine refers to y. So what does tangent refer to?
You have to divide.
Like on this thing.
Like, Yeah,
It would
yeah.
just
Yeah,
be-
because like this first one is cosine and then this one is,
Represent
I
sine.
don't know that yet.
It's just divide, you just have to divide.
I was just trying to like fit in where.
Oh, is that
tangent
what it is?
comes in.
Yeah, well, I mean, what kind of, what would it be?
Opposite or adjacent?
You would take,
Because like sine of,
let me look at the thing here.
because sine of, let's say for example, pi 6 is equal to 1/2.
Right.
And so, because you can look at that chart on that circle, but I don't know how you would find it.
You will have, so you have sine, which is equal to the L and the I. So we want this number, which would be 1. And then you have cos, which is equal to H, and you want that number. So, wait, is it adjacent over opposite
For which one?
For
or
which?
time?
It's opposite over adjacent.
Okay, then time will be this. 1/.
For which one?
For the one you said, P/6, is the one you said?
I said, yeah. Pi
Oh yeah, pi over
Pi over
6.
6. Just as an example. So it'd be what? How do you find that?
I used kind of what you did last time too, that you said that thing is it, and then cos has the adjacent, and then you have time is equal to the specific thing, and I just,
One. So you took the one, oh, you just took the one from there, and then the 3. Oh, okay. And then you would just times that by the square root of 3. So it's not on the bottom. So the radical's not in the bottom. Okay, that makes sense.
Yes.
Did you
So
get
that's
that?
what. Okay.
Okay.
No.
Hold on. Okay.
I can't see it. Okay.
so, you remember, right?
So good to know.
So katawa?
Yeah.
So you have so, and then ka.
So.
And if you see here, they are like that, which is really easy. Then this is the adjacent, and this is the hypotenuse. The same thing with this is the opposite, and then this is the hypotenuse.
Okay.
So I was like,
So you
if
just
that is
took
that, then that is gonna be equal to
is that. Okay. That does make sense.
So you just took like 1 over,
and then it would be then the point would be like that.
Would be like what?
square. So you got, so I'm looking at this.
Because
this
you're gonna
chart.
have the radical on the bottom,
Right.
so you multiply it by 3, you said? By the radical of 3? I forget about those rules, you know, that was a long time ago, so I was like, oh, you can have a radical on the bottom.
Yeah. I usually can't.
Yeah, so you would just multiply the radical by itself. So square root of 3 times square root of 3 gives you 3, and then you times the top by square root of 3, so you square root of 3 with 3.
Perfect.
Okay. Yeah. So that's right.
Yep.
Cool.
I didn't think
Yeah.
do it for a second. That's cool. So I guess you could find any of them that way.
Yeah.
Just
Easy
just
when you
by
get a
knowing
circle.
sine and cosine.
That's really cool.
All right, that makes sense.
I don't understand what it looks like graphed yet, but hopefully we'll get there.
Here's
I
a
have a little
right
white
here.
Yeah. That would be good.
So this is what tangent looks like graph. It's kind of weird.
Okay. And then as compared, yeah, so it's
And
kind
it
of
just like never reaches a certain thing. Hold on. So it's, I think it never reaches tangent. Tangent never reaches like pi 2 pi or something. Or no, I'm sorry, pi
Over 2.
or it never reaches any multiple of pi over 2. Sorry, I'm trying to do touchscreen.
There you go.
So it like will always get like infinitely closer to like pi over 2, which is like 1 point something,
But it never
but it
touches it.
never reaches it.
Okay.
And so any multiple of it, and then like
So then that as compared to
cotangent, I think is the opposite. So there's
Just looks-
tangent, cotangent,
okay.
like never gets close to, or it gets infinitely close to pi, or multiples of pi, but never
Yeah.
gets to it. I don't get this one. These ones are weird.
That's
And cosecant.
oh wow.
So those ones are weird looking. Cosine and sine are always like something like that.
Yeah. Cosine. And then sine. Isn't sine a parabola? Oh.
Sine is, if I like go in here, hold on. Let's add a couple of these. So if I just do regular sine, like not modified over.
Yeah. That looks like
It looks like
it
that.
just looks like that.
And then
Okay.
cosine is like off a little bit. Like, it's the same.
Interesting. Yeah. Sine, cosine. Okay.
Here's all of them.
Yeah. So I'm trying to remember. In my college algebra class before my mission, I think we barely
Yeah.
did some of this.
So
That's
But
all new to me.
yeah, I just remember those shapes, but I don't remember how to get it.
So what do we? Which one are we
So,
on that we're
I think-
discussing?
number 3, just making sure that
Okay.
everybody knows how to do the prep.
So number 6.
We can do
Let's,
like,
let's see, number 6. What is
I
that?
gotta pull that tab open.
yeah, let's just make sure that we can just find one of each,
Yeah, that would be good.
and that way for the quiz.
Math 11.
So using a unit circle,
Yeah.
involving all 6 trigonometric functions. Let's just choose like one of the weird ones. Because we know how to do sine and cosine.
Cool. Oh, that's under preparation.
Yeah,
Number.
number 6.
Number
It's got like a
6.
list of.
So let's do 10.
Oh yeah, yeah. Okay. Cool. So let's pick one.
7.
Which one are you doing?
10.
Tangent of
754.
7/4.
Yes.
Over 4.
Because for me, it's so much easier just to have them as degrees than radian, to be honest.
So, okay. I think I might be understanding this. So, so cotangent is opposite over adjacent, right?
Cotangent
It's
is
adjacent. Oh wait, no.
No. It's adjacent over opposite.
Yes.
Because it's back. It's
Yes, cosine is.
Yeah.
Yes.
adjacent
cotangent.
over hypotenuse.
For cotangent.
Yeah. Or no, I'm sorry, for cosine.
As
Which one did you ask? I'm sorry.
cotangent.
Cotangent is
Oh,
adjacent
just kidding.
over opposite.
Right. Okay.
It's
We're doing
opposite.
tangent. I had it in my head we're doing cotangent. Okay, so tangent.
So that gives me a 315 degree, which means I'm just not sure how he wants the answers to be.
I
Yeah.
think he wants them in radians.
So he.
Or not
I get it.
radians, but yeah, I think he wants them in.
Oh.
Like, so cosine what is it? 7 pi 4 of cosine is square root of 2 over 2, right?
How did you get that?
7
Right here.
pi over 4.
So 7 pi 4. The sine. I'm
That's
sorry.
sine.
Sine is this, and
Yeah.
the cosine is this.
Yeah.
Mhm.
And so sine is
Excuse
opposite over hypotenuse.
I have equal to 1, which is, it would be that.
Be 1.
Because you're gonna
So
have
you take-
negative 2 or negative 2. I mean, it's this.
Yeah,
It
that's
would be equal to -1. But that's the thing. I don't know if he wants it like in -1 or if he wants it in like the root square.
I think he wants them looking like this.
Okay. Well, it will be -1
Probably.
anyways.
Do you see what I'm doing here? This might help.
No.
So on this radian square,
Okay.
so it's dividing pi into fourth. Pi is half of this, or this thing. So 7 pi 4, you'd count. You divide this top part into 4. So 1, 2, 3, 4, 5. Crap.
So if you did 1, 2, 3, 4, those are 30-degree increments. looks
So pi is 180,
Uh-huh.
and so it'd be 45-degree increments. So
Oh, 45.
1, 2, 3, 4, 5, 6, and then you have 7 pi 4
7
right
by
there.
4, right.
And so this is sine, and that's cosine
Mm-hmm.
of 7 pi 4.
Mm-hmm. So then
And
did
so-
you take,
This is sine, so it's opposite over hypotenuse.
right.
And so you would take,
And we need opposite over adjacent, right?
so it'd be
So it'd be
negative
negative
square root of
square
2.
root 2 over,
So I'm right in the camera here.
oh, you're good. I mean,
It's
get to
not-
see us
yeah,
up
it's
close.
yeah. So it'd be and then
And then this one is cosine, which is
adjacent over hypotenuse.
adjacent over.
And we need the hypotenuse part.
Wait,
So
we do? I thought we needed opposite over adjacent
Yeah.
for
for
tangent,
tangent.
Yes. It's opposite over adjacent.
Koa?
So you will have to
So
do
you're right. Sorry.
It's okay.
So you need that
So then you
A-
need
to do square root.
the
square root of 2.
so square root, yeah.
So it's
Mhm.
negative.
Negative
square
square
root
root 2
2.
over square root
Let's
2.
cancel out. So -1 over 1 is -1.
So just -1.
Yep.
Ah. Okay. Look at us, guys.
Yeah, so now we know how to do
Now
this.
we know how to do 10. Let's
Yay.
do cotangent.
Do cotangent.
Which one, the pi over 3?
Yes.
Cotangent?
Pi over 3. Okay.
I have to think these through, but I understand.
Yeah, it does take, it takes a
'Cause I
lot
have
of
to say it out.
flip-flopping.
You have to say so good. A-H. Got it. Like I have to sit there.
So do I, yeah. And it's like has to flip-flop in my brain. Okay, so we're doing cotangent pi over 3.
It
Yeah.
would be square root.
Whoa.
Oh, hold on.
Hold on.
Put it into pi 3.
Okay, over 3. Let's see. Okay, cotangent is adjacent over opposite, right? Is that right? Yeah? Okay. So adjacent, so. That's y. That's 2 on the bottom.
What did you get? Square root of 3.
What do you got?
Square root of 3 over 3. So did it wrong. Hold on. Do it again. Over 2.
I got 2 over 2. Hold on. I think I need to redo that. I know. Okay, sine is.
Cotangent is just a backward of tangent, right?
Yeah.
Yeah.
So it would just be adjacent.
Over opposite.
Wait, maybe
I think it's 2 over 2, guys. So I think it's 1.
why do you think it's 2 over 2? There is not 2 involved.
What?
The 2's are at the bottom, which means they are the hypotenuses, and we're not using hypotenuses. Does that make sense?
Oh, okay, I see what I did. I was looking at
I
the
think I have
secant
that.
and cosecant.
I think it's
You're
gonna be like
I-
1. Did you got 1?
I got when I did it the first time, I got like square root of 3 over
Over
3.
3? Okay, good. Isn't it this one? Where did you
So,
get the other 3?
let me see real quick. Because I had adjacent, right?
Which would be the 1.
So it's
Because I
we're
think I
getting
have it.
adjacent over opposite, right?
It would be
Yeah,
I
yeah,
think I had it
adjacent over
backwards.
opposite.
So it would just
I
be
had it backwards.
over 3. It would be
Oh, you're right. I put it upside down the first time. When I first did it, I had this
I think that's right actually.
this one.
Isn't it? So sin has the opposite.
Opposite over.
Plus have the adjacent, which means that if we look at that, we have
We're trying to find adjacent over opposite.
So
it
yeah,
would be
1 over the
over.
square root of
So you
3,
did it right.
right?
Okay, yeah, and then you would times that by
And then you times that by square root of 3, which cancels out, and it's just 3
square.
or square root of 3 over 3.
Yes, that's it.
Okay, cool. I was
You
like,
did it right.
I did this right.
I
Yeah,
got it
that's
backwards.
Cool. All right, so we know how to find these. It's just
It takes a
Makes
bit, but I think we do.
but it
We
makes sense
understand.
logically in my mind.
Yeah. Okay, that's good. Okay,
Shall we move on, or do you all want to keep practicing?
I think we can
I'm
move
cool with
on.
moving on.
Yeah, I think like it would take more practice to get good at it, but I think we understand how to put in the pieces to make it work.
Okay.
So extension problems.
So I did all of these.
Okay. Graph the following functions. Be sure to identify all 5 transformations. Plot at least one period. This will be done with the 5 important points and identify domain range.
What does
Cool.
he mean with plot at least 1 period?
A period is basically the part before it starts repeating. So like
Oh,
right
so
here.
he just wants 1 period. So
Yeah,
one,
so like this green line is 1 period. If I repeated it,
it would be 2 periods.
so like this right here, if I repeated that, it would just keep doing the same thing.
Okay, so
Okay.
he just wanted 1.
So this kind of stops right where it would start at the end.
Got it. Yeah. Cool.
And so for this one, this first one right here,
Yeah.
what I did is I found like the best order to plot these in
Okay.
is so you start with your regular just sine of x, right? So you graph that.
Because
So I looked up.
we need to
We're basically just trying to find A, B, C, and D. Or wait, no. A, B, C, and D are given to you. We're trying to just plug those
plug
transformations
those in. Yeah. Okay. So.
So the first transformation that you always kind of want to put, I always put A. I just go in order.
Do you? Because I saw
Yeah.
online someone said like the easiest way to do it was like B, C, A, D. But I don't know if that's right. I mean, you can do it any way, but
Because what I do is like with the A, I know how far it will go, so that gives me like the size. If it's gonna be like real big or real small, and then I move it to the horizontal, which
Yeah.
is C, and then I do D. I don't know how to do B in this one. Actually.
B.
B is the period, because I think that was a new one.
Wait, B is what? What did you say?
Period.
A period.
I know how to plug all the other ones because I just think it like a quadratic.
I did B first. So
So I guess B will be done first. I just don't know how.
So this might be kind of confusing to look at, but see the original line that I started with is the green one. Okay, so that's the original.
So
And
that's
then-
B, right?
So this green line was just what I had before I even touched it.
Oh, okay.
And then I added B in,
Okay.
and
Which is
I got
the dotted,
this line right here.
the dotted line there.
Yeah.
Okay.
So you just multiply everything? Like two?
So B, if you look at this, so this is A, B,
Yeah. I just
C,
don't know
and D.
what
and
that
so-
two means.
What the 2x means?
Just the two. What would be the change? Because A stretches of and flips it over and things like that.
I think the period is like
Makes
accordion.
Okay.
Like
Okay,
you'll just smash it this way.
that makes sense. So,
And so
if you have big numbers, it will smash it smaller.
I think so. I
If
have
you
the
have
rules written over here.
Yeah.
0 point something.
Yeah, if
You're talking about
B-
shrinking and stretching?
No,
like,
big
just like
stretching is
accordioning the thing. So if B is greater than 1, it's a compression, and if B is less than 1, it's a
Okay.
stretch.
Then that's all. And how do you calculate then? B.
Calculate
Like
B.
for example, A, if you have a 2, you just go up and down 2. Does that make sense?
I think A is, it's outside of this sign thing. So you find everything else, and then A is applied to it.
Yeah. Yeah, I think that's right. Because you do within the parenthesis first, would make sense.
Yeah, so I find sign of all this stuff. That's why I don't know how you guys are doing it, but I find like what's in parentheses B and C, and then I do A and D.
Yeah.
And so I don't know if that's right, but it worked for me. When I
Yeah,
check it on
I
here,
think.
it
Yeah,
works.
yeah, I think that works.
But one thing they did show is if you have, so this is our problem right here. You have to take the 2 out of this.
Oh, how
And
come?
so, I don't know, I just
Just
read
because.
the directions in the book.
Okay.
So you divide that by 2 and you take the 2 out.
Okay.
If you take the 2 out of pi, you just divide by 2.
Okay.
And so it becomes from that to that.
Okay. So then when you're graphing that, oh goodness, I need to go back and remember how to do that. Because,
So right now it's just, yeah,
because
we don't have this part yet. And we don't have this part. We only have the 2 and the x. So right now you're just multiplying the x by 2.
right.
So for example, here,
That's just what it was.
where
Just
it's
2
x is pi 2. Wait. X-axis. So yeah, if you have x of pi 2, and then you divide, x of pi 2 is 1. Or sine of pi 2 is 1, right? Yeah. So sine of pi 2 is 1. And then if you take that and multiply, wait, how did I get that? Oh yeah, if you multiply it by 2, multiplying pi 2 by 2. So it gives you pi 4th. So it like shrinks.
Yeah.
I don't know if that makes sense. I'm terrible explaining things.
No. I think that
I think I said the
it
wrong
makes more
thing like
sense.
5 times. But so you take pi 2,
Yeah.
and then you times that by 2, and you get pi 4, which is there.
Right.
So all the
it
points
shrinks
are
it.
smashed in.
Smashed in there.
And so
Okay.
the
So
next-
that's for B.
and for the
and for
next
C.
transformation, I have a weird system here. It makes sense to me.
Okay.
But like the more solid the line is, so like there's this dotted line I did first, and then this like weird spidery one. Is what I did next. So minus pi 2. And so give me that for some reason. I can't remember exactly how I did that.
Yeah, that's what it looks like when you actually graph it.
Oh, so it's minus pi 2, so it just moves it over, right?
You're still crossing the vertex. Moves it. Okay.
I
What
can't remember
do
if
you?
it inverted or if it just moved
No,
it
it
over.
doesn't invert it. If it's inside.
It looks like it stretched it. That's what it
It
looks
won't
like.
stretch.
Because I went from this one to this one right here.
Oh, yeah. So you inverted it. Yeah. So it's a reflection.
With just
Right?
that one? Why would that one invert it? That's not what you should do. You should just move it a little bit.
I think
It's
I
just
moved
Scoot
it
it over.
it would just move it to the right.
to the right. Maybe I did that wrong.
It's
Graph it
gonna
real quick
move
just to
it.
check that out.
Yeah. I had, let me grab. I went to the math tutor. Let's see if I can find the scratch paper we were using. Because we went over that.
Oh yeah, it did. I think it did move it to the right, but I just graphed it as if it was over there
It's
because
just gonna move it a little bit.
yeah, because so instead of being here, that's what I did. So instead of this thing being here,
Uh-huh.
it's moved over. But since this is all a continuous thing, this point moved to over here.
Oh,
But
okay.
I just so did this part, and I just moved it onto the visible. That's what I
Okay.
did.
Yeah, I see what you mean. Yeah, oh, okay. So pi over 2, we'll move it over. Yeah. Makes sense.
Yeah, see this right
Oh, no.
Sorry.
Wait, where's the
You just said it like that somehow.
Okay.
Okay, I'm just showing you something real quick and then I'll fix it.
Okay.
So here's where it was.
Okay.
And so then we had this, right? And we add in this.
Which
It just moves
you
it
just
over.
add.
And so that's what I did there.
Okay. Yeah, that
But
makes
then-
sense. You just put it back over so we can see it all together.
So this is the beginning,
Mhm.
and this is what we're at now.
Got it.
Or this is after we did the first step, and this is the second step.
Yeah. Okay. So that's the pi over 2.
Mhm.
Okay. You following this?
Oh,
Yeah. Okay. Good. So then, C. Is that what you
So
do
our-
next?
Yeah, so our next step, I think,
we just did some.
The
I'm sorry,
minus
A.
1.
It would be no, it would be 8.
Yeah.
Oh,
1 over 2.
1 over 2.
Which would be
So-
shrinking it. It would shrink it by a half.
Yeah. So it would make it half of
so
whatever
I
it was.
brought this down. This
Yeah.
point went down there.
Okay. Yes. That makes sense.
And then the last point just shifted the whole thing down to that blue one.
That's what C did. That's what
Yeah.
negative
D.
1
That's
minus
Or
1.
D.
D.
Yeah. So this is green is original,
Mm-hmm.
and then we did B, so the dotted line,
Yeah.
and then I did C, which is this one here.
Uh-huh.
Shrank it a little bit for A,
Uh-huh.
and then moved it
Then
down
moved
with
it down.
D.
That's it.
Yeah, I know all these lines are confusing to just look at.
I know. Wait. How far did you move it down? Because minus 1,
Yeah, so
did that move down 1?
yeah, I did each one of these equals.
Is it half?
It's not even.
So I did 2 lines equals 1.
Okay. Got it.
So move it down
Got it. Cool.
1.
Whew. Yep. That's it.
I guess you can just choose whatever you feel more comfortable doing first.
All I did is I did it with like 2 points and just that way. I didn't have to do it like all of this formula for each one of these
For each
points.
one of them. Yeah.
And then I just kind of eyeballed it, the rest of it.
Yeah. Okay. So what did we need to do with this? We did
I don't know if we need to turn this in. I think we just need to
just to do it.
do it. Yeah.
Yeah. Because identify all 5 transformations, we did that. Plot at least one period, did that. Okay, identify domain. Haven't done that.
The domain would be
Oh, this is
all
what
real
we just
numbers. And the range would be, what was it?
So
What do you have it as?
I had the domain was negative infinity to infinity, and the range was negative 1.5 to 1.5, or sorry, 0.5 to negative 0.5.
You had the range as what?
So the domain is negative infinity. We can plug in any point.
Yeah.
Well, didn't you say that
Exactly.
you made two lines one? So one will be here, right? This is one. So that would be 0.5. Wouldn't it? And this is your graph.
This
so,
is negative 1, and this is negative 0.5.
so it will be negative 0.5 till this one.
Yeah, what did I write? For this,
Negative 1. It
oh,
will be 0.5
yeah.
instead of 1.5.
Oh, but right
Percent?
here is negative 1.5.
Then where do you get the 5?
Right here.
Yeah,
This is
that's
0.5.
that's half of a.
This is negative 1.5.
Oh, okay. I thought you said 5. I was like,
Oh no,
just
sorry.
5?
No, so the range.
Yeah,
We plug in any
the
number. It's going to be on the squiggle line. It's going to be somewhere from negative 1.5 to negative 0.5.
Okay, got it.
Yep. So that one goes with brackets. You got negative 0.5.
I can never remember if it's brackets or.
Yeah, it's brackets.
So it's
because it
brackets.
includes the point.
Okay.
Infinity, negative infinity. Yeah, I always remember brackets as in if it's an actual number, like if it's not infinity, then it's gonna have a bracket. So it,
Oh,
like that's like infinity, the brackets just mean it can keep going in either direction. But I mean,
So the
parentheses,
bracket is
that's what parentheses means it keeps going in either
Yeah.
direction. Brackets means that's where it stops.
brackets are more hard. It's
Yeah, they're
on that number.
final. Yeah.
Okay.
And then 1.5. Cool. Okay, guys, this is starting to make sense. I'm so happy. Okay. So number 2, basically the f of x minus negative 4 cosine, and then 3x plus pi plus 5. So that one, basically the same process we just did.
Yeah.
Right.
And that one will be then flip over because it has a negative in front of it.
Yep.
Yeah. Yeah.
So I have all those too on here as well. If you want to look at that.
Yeah. Maybe we can just walk through it on there.
Okay. Yeah.
And as we're
So let
looking.
me just shut
So let me
this.
write down. Okay. We've got equals f of x equals negative 4 cosine 3x plus 5. Okay.
All right. So the first one is negative. Wait. We were looking
It is
at
3x or 3.
3x. So
It was just shrink it by 3, wouldn't it?
mhm.
So just make it really confusing.
I think I
That
combined a
shrinky
step
is the
there.
one that I need to read about because it's just kind of hard to.
I think I combined a step there. So I
Okay.
shrunk it for this first dotted line. Here's the original.
Yeah.
And then this like really dotted one.
Mm-hmm.
I shrunk it and inverted it like
And
the same
inverted.
step. I don't remember why I
Which-
did that.
The inverted
It's just like the negative.
is the negative. Okay.
Yeah, so I did that on
Got
the
it.
same step. I don't know if I need to. But
Yeah. We'll just.
I think I might have
it's-
messed up there, but I know this is right.
Yeah.
And so I inverted it
Mm-hmm.
and shrunk it. So
Mm-hmm.
instead of this being like this, it's this dotted line now.
Yeah.
So squished it,
Mm-hmm.
inverted, but like the one is still the same,
Mm-hmm.
and one is still the same.
Mhm.
And the next thing I did,
For pi.
yeah, so that was B, and then C. Yeah, plus pi. I just moved it
So you
from
moved it. Mm-hmm.
there to there.
Mm-hmm. Yeah, that looks right. And then
Oh wait, maybe I didn't. I can't remember which one. I forgot to label these ones. Which one I did first?
it looks
So if
like
it was plus pi, it would move this way, right?
Yes.
yeah, you're right. Yeah, because it's opposite of
Okay,
what
so
you
I
think
did
is
this
right.
one first.
Yeah, so you did that right.
And then this dotted one.
Okay, so that's moved over by pi.
Yeah,
Okay.
or maybe I don't know.
No, I do remember
Forgot
yesterday.
to label these ones.
That's okay.
Yeah, if it's close, it's gonna move to the left. If it's negative, it's gonna
Then it's gonna move to the right. Yeah, exactly.
I got that one mixed up because in the quadratic formula it's backwards, and I was like, why is it doing that?
Yeah.
It's because in these formulas, the actual thing is x minus c, which means that if you have a positive sign, c was negative. And that's why it's moving to the left towards the negative side.
Mhm.
So then +5.
You just go up.
You go up by 5.
I might have missed something here. I know the
Yeah.
final one's right.
I know it's
So that's what I wish I would have labeled this. So we started there and we went to either one of those.
yeah.
Um,
That one's not quite up 5, but
yeah. But then
That
it's something stretched it. I can't remember what
4.
the negative
the
4.
-4 would have stretched it.
Okay. So
Oh, I didn't even
That's
see
what I
that
did.
line. That's what that
so
line is.
yeah, that's why I stretched it by 4 there.
hmm
I think I just inverted early.
Yeah. Yeah. But the end one is
And then I
is
moved
right.
it up by 5 to there.
Kind of easier just to do like
Oh,
C, D.
yeah.
It might be.
And plus, like A
So this
and
is
B literally change the shape of the graph.
So
while
this
C
one
and
is your
D
end
change the position
product.
of the graph.
Yeah.
The
It
one
might be
that's
easier to
still
do
not
that from now on for me.
C and D change the position, and A, B change the shape. You know, how stretched or how tall
Mhm.
it is.
So that might be easier to find the shape of it first
And then
before you move it around.
Pre-move it. Yeah.
Okay, I'll try that next time.
Yeah. But that looks good. That looks really good.
And that way you keep track of everything.
Yeah.
Yeah. Okay. So are we good on those?
Yep.
Is there anything else? Oh, let's do the domain and range of that.
Oh.
Domain is.
So here's that shape.
Yeah,
And
and
it'll
take
just
a
keep
look at
going
it.
forever. So
So
we
you've
can put
got
in endpoints.
1 and 9.
Yeah, because it's bottom one is 1,
Oh, I keep forgetting it counts for
top is 9.
with
Nice.
brackets.
Sweet.
Cool.
For me, the hardest part of that is the horizontal. Because it's not an actual number. Because you have D, which is super easy, you just go up.
That's why. Yeah,
And A is super easy.
because this one you move it by like pi 2 or
I know, it's
So
like,
that
what
one's
does
hard.
that even mean?
Yeah, it's hard
well
to
pi
count.
is you're moving at 3.14 something spaces
Five,
over.
da, da, da,
And so pi half of that's like 1.5. So it's hard to graph that.
I think the horizontal and the B stretch can be.
That's why I don't even label this one. I just put pi 2, pi.
Yeah. Yeah, that makes sense.
These really things.
I know.
I think some
Gotta love
gradients anymore.
Anymore.
Okay, so number 2. Transfacial form of the 4 additional functions is the same as before. Difference is that the tangent and cotangent functions have a period of pi and not 2 pi like the other functions. The other 4 additional functions also have asymptote. So
Does that make sense that their period is only pi instead of 2 pi?
So like half a circle
Mm-hmm.
instead of the full circle.
Well, it's the distance pi. So like here's sine, for example, here. This is one period, the red one.
Mhm.
It's from there to there. After that, it's gonna start repeating.
Yeah.
But if you look at the distance, it's from pi to negative pi. So it's 1 pi, 2 pi.
Okay. Makes
So that's
sense.
the period
Mhm.
for that one. And then for these weird ones, oh yeah. For these weird ones, the distance is only like 1 pi. So it goes from,
Because it never reaches 2 pi.
yeah, so it's like 2 pi, it never technically reaches 2 pi, but
Mhm.
close to 2 pi, and then up to,
Close to.
I'm sorry, negative pi
Close.
2 and pi 2. So that's,
Pi over 2. Okay.
yeah,
Okay.
negative pi over 2, pi over 2.
Got it.
So it
Yeah.
never technically reaches either one of those, but that's And so once you got that, you know what the rest is going to be.
Right. Okay, that does make sense. Does anyone know? Do the asymptotes? It's the very last word of number 2.
Also have asymptotes.
It's right before number 2.
Right. It's the last word of number 2 sentence before the bullet point.
The fourth additional functions also have, I don't know. Google that real quick.
Google what that is.
Line that continually. Oh, okay.
Oh, okay. So that's exactly what we just we're looking at. Okay.
Can you show the other ones? The CSC.
Well, I crafted them here, and then I checked them on here.
Mhm.
So tangent and cotangent, they're just kind of like backwards versions of each other. They're slightly different locations too, but
Yeah.
And then this one just kind of looks like this.
Whenever we see.
Like, see which one are we looking at? We're looking at.
It looks like it's pi over 2 away. Constantly.
Which one is it approaching to? Is it not C?
I think it always
B?
approaches 2.
Pi over 2.
2 pi?
Yeah, it always approaches, or no, pi over 2.
Pi over 2.
And never reaches.
But never reaches it. But it can be reflected in any of the axes.
How will you say the range for that one?
The range.
It kind of looks like.
So the range, so for the domain, it's kind of a weird one, but so x can equal, it can be anything except
But-
for pi over 2 and then plus pi of pi times any number. So like pi over 2, but it's never going to reach, like it reaches pi, but it never will reach 2 pi over 2. So if you do plus 1, plus 2, plus 3, minus 1, minus 2, minus 3, it's never gonna,
Okay.
minus 3 pi, it's never gonna.
You're
reach that.
never gonna find it in any of this area.
And it'll never.
And it will never
reach
touch.
negative pi 2. It'll never reach pi 2.
Pi over 2.
It'll never reach 2 pi over 2. It'll never reach 3 pi over 2.
Okay.
And then the period.
So then the way you
I'm
write that.
sorry, the range is negative infinity to 1, or negative 1. And then it starts back up again at 1
Yeah.
to infinity.
Yeah. So and then this this just represents dead space that it can't be.
Yeah.
Okay.
So it can't be in here.
Okay. Yeah. Cool. That makes sense. So
Yeah, its period is 2, because if you cut it here and here,
mhm. And that's for, was that cosecant? Or
that was for
that
secant.
secant? Okay.
Because it can be.
Yep.
And cosecant
Oh, you're gonna
is the same thing almost.
because the tangent and cotangent, those are the ones that look like that can never approach. Those are the ones that are like do the weird, like can never
Yeah, they're like
approach. Yeah, can never approach.
This thing.
Yeah. So that's tangent and cotangent.
Yeah.
Okay.
Tangent, I think, can never approach like pi over 2. And then cotangent can never reach a multiple of pi.
Yeah.
So one can't reach a multiple of pi, and the other one can't reach a multiple of 2. Oh yeah, pi over 2.
Yeah, it makes sense. And then we just did secant, which looks like this. That can never reach pi over 2 or negative y over 2. Okay, so now the
Or
last
any
one,
multiples of those.
or any multiples, yeah. So,
So secant has the same domain as tangent.
oh, wait.
So these two right here,
Uh-huh.
they'll both be infinitely approaching
So secant.
pi over 2.
Pi over 2?
Yeah.
Okay.
They're both never reach it.
That's secant
Cotangent, you
and
say? Cotangent.
cotangent.
Tangent?
Tangent equals domain.
Yeah. Okay, interesting. So it's good to know the relationship there. And then
Yeah, I just saw it.
that works. And the last one's cosecant.
Yeah. And so that one is kind of the same way. So like you have, here's secant.
Uh-huh.
And then secant is kind of
Or cosecant?
So there should be another one there. But
That's cosecant.
yeah, cosecant. So there's secant here
Mhm.
and cosecant.
It's just off that. So kind of like tangent and cotangent.
Yeah.
Basically.
And so this one can never, it can never get close to, or it can never reach a multiple of pi for the domain.
And that
Mhm.
is secant or
Cosecant. You can look at this if you need to.
go to the cotangent in the range. In the domain. Right?
For the range of the domain.
For the domain, cosecant would be the same as cotangent.
Cosecant is the same
It's like as tangent is the as cotangent is the tangent, so it's cosecant to secant. So the relationship there.
yeah, so you're asking about cosecant? Here is, so cosecant can never reach a multiple of pi.
And cotangent?
Cotangent, yeah, can never reach.
So it's the same thing.
Yes. But cosecant, its range
It's the same
is the same as secant.
which is the same thing for tangent and cotangent.
Yeah, cotangent and tangent have the same range.
Domains are different, but their range is the same.
Yeah, secant and cosecant have the same range, but cosecant and cotangent have the same domain. Secant and tangent have the same domain.
Whoa. Say that again. So secant and cotangent have the same domain?
Secant and
tangent?
tangent have the same domain. Cosecant and cotangent have the same domain.
Got it.
And then tangent and cotangent have the same range. And secant and cosecant have the same range. So it's like if you just square,
Yeah.
you have these relationships between each other.
Yeah, I got it now.
Make a square.
Makes life easier. Cool.
I tried to see if that would be the rule for all, like, because you have opposites have the same range, but not really. No. Because
I don't know.
it only works with tangent and cotangent that have the same range, and they're opposites to each other.
I wonder how much of this the teacher actually watches.
Probably not.
It is real long. I
Well,
think we just put it
'cause
like
we
full
got-
speed.
what do we got right now?
We've
We
just been good amount.
Like an hour
Like
and
40 minutes.
20
Something. So she doesn't have like 30 some hours in her day, even
No.
if she wanted to.
no. Wait, I thought it was a guy.
Is a guy.
Yeah, sorry. Sorry, I haven't been a teacher that long.
It's fine.
I'm sure he watches.
If,
like, the
if he
first-
watches that, then he'll get a laugh.
Yeah. I think he just watches like the first part and he's like, all right, who's here? Cool. And like, that's what I would do.
That's what I would do too. It's like, I
Yeah.
would include it. If they talk about it, it's their problem.
Yeah, what are they doing? Are they playing beer pong? Are they, yeah.
Okay. So where are we now?
I was gonna say the period.
Was experience functions.
I think we just did that.
Woohoo!
Identify period false.
I think we're done with the GHOE.
Wait, did we do the period? Oh yeah, we
Yeah,
did.
yeah,
Oh,
it's
yeah,
there.
yeah. That's the P.
And then the 2P. Right. Yes. Tangent is
Pi,
2P.
pi over 2. Oh wait, tangent.
Pi, that's what I mean. When I say P,
I figured.
Tangent has a period of pi, cotangent has a period of pi, secant has a period of 2 pi, and cosecant has a period of 2 pi.
Pi over 2.
So
2
secant
pi.
and tangent is 2 pi.
There's a period. Oh, period. Okay.
Period, yeah.
Yep. Okay.
Co-
Got it.
So cosecant and secant have a period of 2 pi.
2 pi. And then tangent and cotangent of pi.
Yeah, I think we're ready to start
Whew,
this.
I think we
quiz.
are. Yep. I think we are done with the group quiz. That's
Nope, so I'm gonna go ahead and
Stop it. Bye.
see you later.
Step.
I'll post this later.